According to a recent study, there will be 26 billion devices connected to the network in 2020. Most of them will be connected with wireless, and a lot of that connection has already taken place. Cattle have transponders clocking their every movement. Heart monitoring implants check their clients' vitals and send the information directly to their cardiologist. Your car tells you when to put air in your tires. What's important for understanding wireless is how all these devices communicate with one another. Who decides what part of the spectrum they use? How can we prevent interference? And is there a way to make all of this pay for itself?
Understanding wireless will explore the critical legal and policy challenges that wireless technologies raise. We'll study the principal agency responsible for regulating telecommunications in the United States, the Federal Communications Commission, or FCC. We'll ask how the FCC historically has regulated the radio spectrum, how it does so now, and how it should do so in the future. As the FCC continues to wrestle with network neutrality principles that dictate how broadband providers carry traffic on their networks, we'll ask how those principles should apply to wireless carriers. Finally, we'll consider the fundamental privacy concerns that wireless technologies raise, particularly in their ability to generate data about a user's location. Throughout the course, we'll ask how rapid technological change and technological convergence challenge policymakers and users alike.
In this course, we will look at wireless as it applies to networking. We'll start off with basic networking principles, looking at how does the internet actually operate. And in particular, we'll focus on what are the unique challenges that wireless brings to the devices that we use wirelessly. We'll look at 3 different technologies over the course. We'll start off with Wi-Fi. We'll look at the nuances of what unlicensed spectrum and distributed coordination mean. From there, we'll look at the evolution of how cellular technology has occurred. We'll look at the standards bodies, how we started off with very simple analog cell phones and moved over to data-rich 4G LTE phones to provide pretty much any sort of content that we would like. Finally, we'll wrap up with the Internet of Things, which is a really exciting technology that looks at how low power, always-on devices provide essentially an unlimited stream or perspective of the world around us, and how this is going to fundamentally transform how we interact with everyone.
From a radio technology perspective, understanding wireless will provide a high-level overview of the physical laws that govern the propagation of electromagnetic waves, and a basic summary of the circuit components that enable the conversion between information, electric currents and voltages, and EM waves. We will review technology trends that have led to the modern smartphone, from migrating between analog and digital transmission, to making better use of the available radio spectrum, to reducing the effects of interference. Finally, we will review several technology innovations that are likely to be the cornerstones of next-generation radio systems. To be successful in this course, you should expect to spend 5 to 7 hours per week. Each week, you will have assigned activities and homework. Deadlines will count, so staying on schedule will be important to your success.
There will also be several opportunities to engage with peers from around the world.
We are excited that you are joining us to increase your understanding of wireless. We hope that by the end of this course, you will be a more informed wireless user.